Hi students, it is the fourth day, part 2 video of lesson gravitation from science part first. So far we have discussed the acceleration due to gravity. The object which is falling down, as it is coming downward, definitely distance in between the object and the center of earth decreases, and as the distance decreases, then definitely force increases. As force increases, velocity goes on increasing, and so change in velocity is nothing but the acceleration, and this acceleration is going to happen due to gravity. So this acceleration is called as acceleration due to gravity. So what is the formula we have discussed? That acceleration due to gravity is equal to gravitational constant into mass of earth divided by distance square. Within that term, what is G? G is gravitational constant, M is a mass of earth, and R is the distance of object from the center of earth. Whether it is on the surface of earth or above the surface of earth, we should measure this distance from the center of earth. So while discussing within that video, we have discussed what is the value of G. G is equal to 9.77 meter per second square. That is the value we have discussed. Then again, one important part we have discussed. Within this formula, G is dependent on gravitational constant, which is constant one. G is dependent on mass of earth. Mass of earth is always constant. And here, what changes? That only distance in between the object and the center of earth. So in this case, G is totally dependent on R, or a distance in between the object and the center of earth. If it changes, then value goes on changing. See, G is gravitational constant, but acceleration due to gravity is not constant. It can vary. It is totally dependent on the position of the object. Again, one thing is that here this acceleration due to gravity is equal to this much only. Here we do not having any value for M. M is a mass of object. So this M do not having any place within this formula, and so we can conclude that that is acceleration due to gravity does not depend on the properties of object. Whatever may be the object, acceleration due to gravity is same for all the objects. Now, acceleration due to gravity changes according to this R. So, how it changes? Is the value same everywhere? That we are going to discuss, and that is the topic of this lecture. See, variations in the value of G. First is there change along the surface of earth. As location on the earth changes, the value of G, that is acceleration due to gravity, get changed. How it is? See, along that surface of earth. When we discuss the sphere, this one is a sphere. So within the sphere there are two radius. Suppose earth is a spherical. Suppose this one is the north pole, this is the south pole, and this is considered as the equator. Then if it is a sphere, then the center and north pole, that is a radius, and center and one point on the equator, that is also a radius. So both the radius are same. Why? Because we have considered earth is a spherical one, and within this case R1 is equal to R2. That means radius at equator is equal to radius at pole, any pole. This one is the radius at equator, this one is the radius at any one pole. When is going to happen? When we consider earth is spherical. But as we are focusing on the shape of earth is not a spherical. Then how it is? It is not exactly spherical. It is bulged at equator. Little oval shape. It is bulged at equator and flat at pole. When object is bulged at equator, means center to one point on the equator, that radius we are going to consider as a R2. And North Pole or South Pole, any one pole we are considering, this distance is called as R1. Within this case, R2 is equal to R1, but here R1 is not equal to R2. Because Earth is little flat at pole, bulged at equator, so definitely R1 is greater or R2 is greater. So within this case, R2 is greater. And so here R1 is less than R2, that means R2 is greater than R1. Just we have discussed here only, gravitational force is depend on distance, like this one. Acceleration due to gravity is also depend on distance. Distance increases, definitely acceleration due to gravity decreases because inverse proportion. So within which, where is the radius more? Radius is more at equator, less at pole. So less at pole, definitely acceleration is more, and so at pole we having acceleration due to gravity 9.832 meter per second square because distance is less. What about here? At equator we having the longest radius. As we having the longest radius, definitely acceleration due to gravity is smallest, and so that is 9.78 meter per second square. So what is the conclusion? When radius Earth is not exactly spherical, it is flat at pole, bulged at equator. So radius at pole is less and radius along equator is greater. Less the distance, more the acceleration. More the distance, less the acceleration. And according to this, we having the less distance or less radius, definitely acceleration is more, and here longest radius, so smallest acceleration we having along the surface of Earth. So how is the change? Suppose someone is moving from North Pole to equator. North Pole to equator, that means altitude is decreasing. So as there is a decrease in altitude, definitely acceleration due to gravity goes on decreasing. So North Pole to equator, acceleration decreases. Equator to South Pole, see distance decreases now, so acceleration increases. South Pole to again equator, distance increases, so acceleration decreases. And this equator to again North Pole, distance decreases, so definitely acceleration due to gravity increases. So someone want to move along the surface of the Earth, how many times acceleration due to gravity changes? See, first decrease, decrease to again increase, increase to decrease, and decrease to again increase. So one time, second time, third time, and fourth time. In all, 4 times acceleration due to gravity changes. So how is the change? Acceleration due to gravity is the highest at pole, that is 9.832 meter per second square, and it is the lowest at equator, that is 9.78 meter per second square. So radius is not same, and so acceleration due to gravity is not same everywhere on the surface of Earth. That is related to only when object is on the surface of Earth. The second point we are discussing, how the value of g, that is acceleration due to gravity, changes according to change with height. See, this one is Earth. Then from the center to surface, we are not focusing where the object, it is a North Pole or equator or in between that. Not considering it is on the surface of Earth only. Then generally, we should consider radius of Earth is 6,400 km. Now, focus on the object which is just little above the Earth, that is 10 km only. Suppose that is an aeroplane. Suppose this is the location of aeroplane we have. So what is the distance here? Here distance is only 10 km. Then as compared to 6400 km, this change by 10 km is so small. So within this distance, though there is a little change in g, this change is negligible. So for the smaller distance, we are considering the value of g, that is 9.77 or 9.8. One time it is little less, one time it is little more. So by reducing all this factor, we have taken the mean, that is acceleration due to gravity at pole, then acceleration due to gravity at equator, and the mean means addition of both divided by 2, and that value is 9.8 meter per second square. That is, we are taking as a acceleration due to gravity when objects are on the surface of Earth or near the surface of Earth. Though it is 10 km, a little effect is there, so that change is negligible. But now we are focusing on the next point now. The object is at point A, and what is point A? How much distance we having in between center and the surface? The same distance we having here. Then if this distance is r, so definitely this distance is 2r, that is twice of r plus this one again r. So in between center and A, we having 2r distance. So acceleration due to gravity is inversely proportional to r square. Then what is the value we are getting here? See here, we are getting g inversely proportional to 1 upon 2r square. That is g inversely proportional to 4r square. So as we consider this is constant, it is decreases. 1 upon 4 means decreases by 4 times. Acceleration due to gravity decreases by 4 times. Now consider again increase the distance. Now just you have taken that object from point A to point B by again distance r, that is again same distance we have taken. So totally the distance in between this point, that is center of Earth, and this point B is now 3r. So as distance is 3r, then g is proportional to 1 upon 3r square whole square. That means g inversely proportional to 1 upon 9r square. So 1 upon 9 means acceleration due to gravity decreases by 9 times. So what is our conclusion? As height increases from the surface of Earth, acceleration due to gravity goes on decreasing. As per height, it will goes on decreasing, or it starts to reduce. So according to textbook, we having information on the surface of Earth, acceleration due to gravity is 9.8. Mount Everest, that is 8.8 km from the surface of Earth, and so the gravitation is again 9.8 because this change is negligible. But when maximum height reached by the man-made balloon, that is 36.6 km, and here we are getting little change acceleration, that is 9.77. Then the height of typical weather satellite, they are 400 km from the surface of Earth, and there we having acceleration due to gravity 8.7 meter per second square. And lastly, we have the information height of a communication satellite that are 35,700 km from the surface of Earth, and their acceleration due to gravity 0.225. So what is our conclusion? As height of object from the surface of Earth, that is from the center of Earth, increases, acceleration due to gravity decreases. After this, the third point is how value of g changes according to change with depth. See now. The outer circle, this circle indicates the surface of Earth, and this one is the center. Now object is here, and the distance in between the center of Earth and the object, because it is on the surface of Earth, is r. That is the radius, as per the radius. Now we are going down. When we go down, 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 and the object is here, how much is here? That is r divided by 2. That is, how much is r? Half of that. Then see here, when distance decreases, now object is here. The distance in between, this is case number first and this one is case number second. Within the first case, that is acceleration due to gravity is inversely proportional to, that is g m divided by r square, that is r square only. Now what is the second case? G is inversely proportional to g m divided by r divided by 2 square. So g inversely proportional to g m divided by r square divided by 4. So here g inversely proportional to gm divided by 1 into 4 divided by r square. So g is inversely proportional to 4 gm divided by r square. That means according to this formula, as depth goes on increasing, the distance in between that object and center goes on decreasing. So according to this law, what should increase? There should be acceleration, should increase or not. So see here, as we have considered 4 times, but where we have to focus a lot, this formula, within this formula, we have focused only on r. What about that mass of Earth? See here, when object is at location first, this total mass of object should be considered or not. But when object is removed to location 2, when this point is A and this point is B, now see, by taking this much radius, we have to draw the circle or not, or we have to prepare a sphere or not. So mass decreases or increases. Definitely when object was at A, total Earth was considered as a second object. So total mass we are going to consider. But when object is moved from A to B, this distance decreases. So by taking BC as a radius, we have to consider the sphere, and that sphere's mass decreases. So here mass is also changing and radius also changing. According to radius, definitely acceleration due to gravity increases. But as compared to this increase, it is directly proportional to mass, and so mass decreases, so acceleration due to gravity decreases. So according to r, acceleration due to gravity increases, but according to mass, because reduced mass, acceleration due to gravity decreases, and this decreases more than the increase, and so in result it decreases. See here, why? Because when we reach at the center of Earth, when you reach at the center of Earth, mass of Earth is 0. And when mass of Earth is 0, that means g into 0 divided by r square. And this value we are getting 0 or not. And so, acceleration due to gravity at center is 0. So, where is at the climax? See here. Highest gravitation, acceleration due to gravity is at surface. As you move upward, it decreases and becomes 0 at certain level, and as you are going downward, at center again 0. So as you are moving from highest to 0, that means definitely there is a decrease. Getting it now? So as there is decrease in the depth or change in the depth, definitely acceleration due to gravity that is decreases. From surface to center, definitely decrease, then 0, and then increase, here highest. If you start from this location, acceleration due to gravity is highest here on the surface of Earth. As you are moving towards the center of Earth, it becomes 0. From that center to against surface it is highest. So where we having the highest acceleration due to gravity? On the surface of Earth. Where we having the zero acceleration due to gravity? At the center of Earth. What is the conclusion? Acceleration due to gravity do not depend on mass of object. It is depend on distance and mass of Earth. In some cases only. Where it is that according to surface it is highest at the pole, lowest at the equator. According to height, as height increases, acceleration due to gravity goes on decreasing. And according to third point, change with the depth. As depth increases, object is moving nearer to the center. Radius decreases, along with that mass also decreases of Earth, and so result is decrease in the acceleration due to gravity, and it becomes zero at the center of Earth. Thank you.